The throttle shuddered in his hand. At Mach 0.9, the aircraft began shaking in ways no training manual had warned him about. Squadron leader Sarfaraz Ahmed gripped the stick tighter as the vibrations intensified, rattling through the airframe like a warning from the machine itself. At Mach 1, the shaking became violent. Structural. The kind of tremor that tells a pilot his aircraft is about to tear itself apart around him. For one terrifying moment, thousands of feet above Chinese soil, Ahmed thought he was going to die. Not in combat, or not defending his homeland, but in a training flight, strapped into a Chinese copy of a Soviet fighter that suddenly felt like a coffin with wings. He chopped the throttle, began a careful descent, his heart pounding against his flight suit as he waited for the airframe to fail. But the vibrations subsided. The aircraft held together. He landed safely, hands still trembling on the controls. When Chinese technicians inspected the aircraft, they found nothing wrong. Some vibration at transonic speeds is normal, they told him. Other aircraft in this batch have similar characteristics. Similar characteristics. That phrase would haunt Pakistani pilots for years to come, because what Ahmed had just discovered, what dozens of Pakistani aviators would soon learn for themselves, was a truth that no official briefing had prepared them for. These were not MiG-19s. Whatever the designations said, whatever the Chinese promised, these aircraft were something else entirely. Something that would test their skills, their courage, and their ingenuity in ways they never anticipated. This is the untold story of how Pakistan acquired Chinese fighters that were demonstrably worse than the Soviet originals they copied on. How Pakistani pilots turned those deeply flawed machines into genuine weapons of war through sheer determination and professional excellence. If you find stories like this fascinating, take a moment to subscribe and hit that like button. Your support helps bring more of these hidden chapters of military aviation history to light. But to understand what those Pakistani pilots faced in 1966, we need to go back further. Back to where this story really begins, not in China. Soviet aviation engineers were locked in a desperate race with the West. The Korean War had proven beyond doubt that jet combat was the future of aerial warfare. American F-86 Sabers had fought Soviet-designed MiG-15s to a bloody standstill over the frozen Korean peninsula. Moscow's leadership demanded something better, something faster, something that would give the Soviet Union undisputed dominance in the skies. The task fell to the Mikoyan-Gurevich Design Bureau, the legendary MiG, whose fighters had already shocked American pilots over Korea. Artem Mikoyan and Mikhail Gurevich gathered their best engineers in a facility where failure meant more than lost contracts. In Stalin's Soviet Union, it could mean Siberia. Or worse, the challenge was immense. Breaking the sound barrier was one thing. Chuck Yeager had done that in 1947, but creating a production fighter that could routinely operate at supersonic speeds while remaining controllable and combat effective was something entirely different. Every aspect of the aircraft had to be reconsidered. Wing sweep angles, engine placement, control surface effectiveness at speeds where air itself behaved differently. What emerged from that pressure was the MiG-19, the Soviet Union's first production supersonic fighter and one of the most significant aircraft in aviation history. Powered by twin Tumansky RD-9B afterburning turbojets, the MiG-19 could exceed Mach 1.3 in level flight. When it entered service in 1955, nothing in Western arsenals could match it. Soviet test pilots reported that the aircraft handled beautifully at high speeds, responding crisply to control inputs, even as it punched through the sound barrier. The swept wings and sleek fuselage represented the absolute cutting edge of aerodynamic knowledge. But speed wasn't everything. MiG-19 carried teeth 330mm NR-30 cannons with devastating firepower. Each cannon fired approximately 900 rounds per minute. The heavy 30mm shells could tear through any aircraft structure with ease. A single well-aimed burst could destroy an enemy fighter, making the MiG-19 a fearsome opponent in the turning dogfights that characterized air combat of that era. The aircraft demanded respect. It demanded skill. But it rewarded pilots with performance that seemed almost magical by 1950s standards. Soviet pilots who mastered it considered themselves elite members of a select brotherhood who could fly faster than sound itself. And almost immediately, Moscow began sharing this remarkable technology with its communist allies. This was standard Cold War practice. The Soviet Union built networks of allied states equipped with compatible military hardware, expanding influence while creating a buffer of armed friends around its borders. Among the most important recipients was the People's Republic of China, then still considered a close ally. Despite tensions between Beijing and Moscow that would soon tear the communist world apart, in 1958, the Soviets agreed to provide China with complete manufacturing documentation for the MiG-19, along with sample aircraft and technical advisors. The Shenyang Aircraft Factory was designated to produce the Chinese version, the J-6 domestically, F-6 for export. Soviet engineers arrived to set up production lines, train workers, and ensure quality control. For a brief moment, it looked like genuine cooperation between communist giants, a partnership that would strengthen both nations against the capitalist West. But beneath the surface, the relationship was poisoned. And the poison had a name: ideology. Mao Zedong increasingly resented what he perceived as Soviet condescension. He bristled at Khrushchev's criticism of Stalin, whom Mao admired, and rejected Soviet advice on economic development that conflicted with his own radical visions. Nikita Khrushchev, for his part, was alarmed by Mao's rhetoric about nuclear war. Mao had famously suggested that China could survive and ultimately win a nuclear exchange due to its massive population. The statement horrified Soviet leaders who actually understood what nuclear weapons could do. The ideological split widened with each passing month. Disputes over Marxist theory, border territories, the proper strategy for spreading revolution worldwide. Underneath it all, the oversized egos of two men who each believed himself the rightful leader of global communism. During summit meetings, Mao and Khrushchev clashed repeatedly. Khrushchev's rough peasant manner offended Mao's sense of dignity. Mao's cryptic pronouncements infuriated Khrushchev's practical sensibilities. Neither would defer to the other. Neither could. Then, in 1960, the breaking point came with stunning speed. Khrushchev, furious over Chinese provocations, made a decision that would reshape Asian military aviation for decades. He ordered the complete and immediate withdrawal of all Soviet technical advisors from China. The order was executed with brutal efficiency. Overnight, approximately 1,400 Soviet engineers, technicians, and specialists began packing their bags. Within weeks, every single one had departed, leaving behind factories, laboratories, and military installations that suddenly lacked the expertise to function. But they didn't just leave. They took things with them: critical technical documentation, manufacturing specifications, quality control procedures that hadn't yet been transferred to Chinese counterparts. In some cases, Soviet advisors deliberately destroyed documents rather than leave them for the Chinese. Years of cooperative work was undone in a matter of days. When the last Soviet advisor's plane lifted off Chinese soil, it took more than expertise with it. It took the blueprints for the future. The Sino-Soviet Split was complete, and at the Shenyang Aircraft Factory, production of the J-6 ground to a halt almost overnight. Chinese engineers found themselves stranded. Incomplete blueprints, partially explained manufacturing processes, equipment they didn't fully understand, aircraft in various stages of assembly that they couldn't complete. The Soviet advisors had been integral to every aspect of production, and their departure left gaps that couldn't easily be filled. What followed was one of the most ambitious reverse engineering projects in aviation history. Communist Party leadership ordered Shenyang's engineers to figure out how to build the MiG-19 using whatever documentation remained, and by studying the completed aircraft the Soviets had left behind. Failure was not an option. The party demanded results. And in Mao's China, engineers who failed to deliver risked more than their careers. The challenge was staggering. The MiG-19 wasn't a simple machine. The Tumansky RD-9B engines alone contained thousands of precision components manufactured to exacting tolerances. Turbine blades had to withstand temperatures exceeding 1,000 degrees Celsius, while spinning at tens of thousands of RPM. Compressor stages had to be balanced to microscopic precision, or the engine would shake itself apart. The airframe required specialized aluminum alloys and heat treatment processes that Chinese metallurgists had to reverse engineer from Soviet samples. The avionics demanded electronic components that China's electronics industry simply couldn't produce in sufficient quantity or quality, so the engineers at Shenyang did what they could. They disassembled Soviet-built MiG-19s down to the smallest components, measured everything, photographed everything, documented everything in painstaking detail. They created their own blueprints based on reverse engineering, often guessing at specifications the Soviets hadn't shared. And when they encountered materials they couldn't replicate exactly, they substituted whatever was available from Chinese industry. This is where the problems began. Soviet metallurgy was among the most advanced in the world, the product of decades of intensive research. The special alloys and MiG-19 engine components were designed to withstand extreme temperatures and mechanical stresses for thousands of operational hours. Chinese metallurgists working without Soviet research often produced alloys that looked similar on paper, but performed differently under stress. Turbine blades made from Chinese materials might work adequately in peacetime training flights, but under the sustained high temperatures of combat operations or extended afterburner use, they could fail catastrophically. The differences were invisible to inspection until the most demanding moments when pilots needed their engines most. Manufacturing precision posed similar problems. Soviet factories maintained tolerances developed through years of quality control, supported by precision machine tools and experienced workers. Chinese factories in the early 1960s worked with less capable equipment and less experienced personnel. Components that should have fit together perfectly required hand-fitting by skilled workers. Assemblies that should have been interchangeable often weren't. Every J6 that rolled off the Shenyang line was subtly different from every other. Some engines ran hotter. Some airframes had structural weaknesses. Some avionics were miscalibrated. Each aircraft had its own quirks, its own personality, its own potential problems. Every J6 was a gamble. Some pilots would win that gamble, others wouldn't. Despite these challenges, China pressed forward as a matter of national pride. By the mid-1960s, J-26 fighters were entering service with the People's Liberation Army Air Force. Communist party propaganda celebrated them as evidence of Chinese self-reliance and industrial capability. But the pilots who flew these early J-6s knew a different truth. They developed informal assessments of individual aircraft, noting which ones could be trusted at high speeds and which should be flown cautiously. They learned to recognize warning signs of impending mechanical failure. They developed emergency procedures for situations that should have been impossible but occurred with disturbing regularity, half a world away. Events were unfolding that would bring these problematic Chinese fighters to South Asian skies. The roots of Pakistan's crisis lay in the bloody partition of British India in 1947, which created two nations locked in perpetual rivalry over Kashmir. Both claimed the territory entirely. Both were willing to fight for it. The First Indo-Pakistani War ended inconclusively in 1948, leaving a ceasefire line that satisfied neither side. In September 1965, tensions finally boiled over into full-scale war. The conflict lasted only 17 days, but it was intense. Major armored battles, sustained aerial combat. The Pakistani Air Force performed admirably, achieving a favorable exchange ratio against the larger Indian Air Force despite being outnumbered. Pakistani pilots flying American-supplied F-86 Sabers and F-104. Starfighters demonstrated exceptional skill, claiming numerous Indian aircraft while suffering relatively light losses. Flight Lieutenant Muhammad Mahmud Alam became a national legend during the conflict, credited with shooting down 5 Indian aircraft in a single day, including 4 within a single engagement. The exact details remain disputed by historians, but his achievement, whether precisely accurate or somewhat embellished by wartime propaganda, demonstrated that Pakistani pilots could compete with anyone in the world. The Air Force emerged from the war celebrated as national heroes, but the conflict had also exposed a dangerous vulnerability. Pakistan's entire military capability depended on continued American willingness to supply weapons, spare parts, and ammunition. And then Washington pulled the plug. The United States, angry that American weapons had been used in a war it hadn't sanctioned, imposed an arms embargo on both India and Pakistan. For Pakistan, the consequences were immediate and devastating. Spare parts stopped arriving. Engines that needed overhaul couldn't be serviced. Instruments that failed couldn't be replaced. Ammunition stocks couldn't be replenished. The Pakistani Air Force, which had just proven its worth in combat, was slowly being grounded by logistics. Operational readiness plummeted as aircraft became unflyable one by one. Pakistan's military leadership searched desperately for alternative suppliers. The Soviet Union was out Moscow, had close ties with India. Western European nations wouldn't antagonize Washington. Britain, France, and others valued their American relationships more than Pakistani arms sales. That left China. China shared Pakistan's suspicions of India. In 1962, Chinese forces had routed Indian troops in a brief Himalayan border war. Beijing saw Pakistan as a useful counterweight, friendly nation on India's western flank that could divide Indian attention and resources. The relationship had been warming throughout the early 1960s. Now, as American supplies dried up, Pakistan turned to China in earnest. And what China offered was the J-6. Chinese officials presented it as equivalent to the Soviet MiG-19, a proven supersonic fighter, impressive specifications, powerful armament, proven design heritage. The J-6 was affordable, available in quantity. It came with no political strings. China wouldn't impose embargoes over policy disagreements. Better still, Beijing offered training, spare parts, and eventual technology transferred the possibility that Pakistan might someday produce its own fighters and never again face the humiliation of a supply cutoff. The strategic logic was compelling enough to overcome whatever doubts existed about Chinese manufacturing quality. But what happened next would change everything. The first Pakistani pilots sent to China for J-6 training arrived in the summer of 1966 with emotions that mixed hope and apprehension. Many had flown American aircraft. They were accustomed to F-86 Sabers products of an industry at the peak of its capability, built to exacting standards with quality control that Americans took for granted. They'd heard rumors about Chinese quality problems. They hoped the rumors were exaggerated. Squadron leader Sarfaraz Ahmed was among them. A veteran pilot with hundreds of hours in American aircraft, he approached the J-6 with professional curiosity. The aircraft looked impressive, enough swept wings, twin engines, a modern silhouette. Chinese instructors were professional and thorough. The training program covered everything from basic handling to combat tactics and emergency procedures. The Chinese were clearly proud of their aircraft. Pakistani pilots wanted to share that confidence. Then they started flying. The first thing Ahmed noticed was the inconsistency between individual aircraft. In American service, pilots moved from one F-86 to another, knowing each would handle identically. Standard production ensured that every aircraft was essentially a clone of every other. The J-6, each aircraft had its own distinct personality. Some pulled left, requiring constant right rudder to fly straight. Others pulled right. Some engines ran hotter than instruments indicated. Some cockpit instruments were miscalibrated. Pilots had to learn the quirks of their specific aircraft and adjust accordingly. This was manageable in training. But in combat, where pilots might fly, whatever aircraft was available, it created serious complications. The engines were the deepest concern. The Wapen WP-6 power plants were Chinese copies of the Soviet RD-9B, and they demonstrated every problem of Chinese reverse engineering in concentrated form. Fuel consumption ran higher than specifications, reducing already limited range. Throttle response was sometimes unpredictable, engines surging or lagging unexpectedly. Slight variations between left and right engines created asymmetric thrust that pilots had to constantly correct. Most worrying, the Chinese engines had significantly shorter service lives than Soviet originals. No. Soviet RD-9Bs were rated for hundreds of hours between overhauls. Chinese copies showed wear and damage at a fraction of that interval. Turbine blades eroded faster. Compressor stages accumulated damage more quickly. Bearings wore beyond normal rates. More frequent overhauls meant more downtime. More maintenance meant more opportunities for errors that could cause failures in flight. And then there was Ahmed's transonic experience, the violent shaking at Mach 1 that no manual had mentioned. Other pilots reported similar incidents. Aircraft that buffeted unexpectedly. Vibrations that felt structural rather than aerodynamic. Moments of terror at high speed. Chinese technicians always found nothing wrong. Normal characteristics, they said. Pakistani pilots learned to live with it, but they never fully trusted their aircraft at high speed. The onboard systems added to the frustration. The radar-ranging gun seat, a copy of a Soviet design, was notoriously unreliable. It frequently gave inaccurate range information, making accurate gunnery far more difficult than it should have been. Pilots learned to distrust it and rely on judgment and experience instead. Radio equipment was prone to interference with limited range compared to Western systems. Navigation instruments drifted. Compasses pointed several degrees off true north. Attitude indicators developed errors that weren't immediately apparent. Pakistani pilots learned to trust nothing without verification. They constantly cross-checked instruments, used external references, maintained awareness that any reading might be wrong. It was exhausting over long missions and dangerous when weather limited visual references. Even the cockpit environment reflected Chinese limitations. Controls were awkwardly placed, throttles positioned uncomfortably. Emergency handles weren't where instincts suggested they should be, requiring conscious thought during situations demanding immediate reflexive action. And the ejection seat the system pilots might depend on for their lives had developed a reputation for unreliability. Reports from Chinese service suggested J-6 ejection seats sometimes failed to fire, sometimes fired with insufficient force, sometimes fired asymmetrically and injured pilots who should have been safely separated from their aircraft. For pilots who flew knowing ejection might be necessary, this added anxiety to every flight. And this is where the story takes a darker turn. Despite everything, Pakistan proceeded with large-scale acquisition. The strategic logic was simply too compelling. Pakistan needed fighters immediately. The J-6 was available, affordable, and came without political conditions. The aircraft's shortcomings would have to be managed. The Pakistani Air Force designated its aircraft F-6 South and began the complex process of integration. This required adaptation at every level, and it would ultimately become a case study in human determination, overcoming technological limitation. Maintenance crews faced the greatest challenge. Many had trained to American standards during the era of close U.S.-Pakistan cooperation. They understood what quality maintenance looked like. They refused to accept Chinese manufacturing problems as inevitable. Senior technician Mohammed Hussaina, veteran of American aircraft maintenance, led efforts at PAF base Sargata to develop modified inspection procedures. When Chinese manuals didn't document certain wear patterns, Pakistani crews created their own inspection intervals based on actual experience. When components didn't meet specifications, they developed workarounds to make imperfect parts function reliably. They maintained meticulous records of every aircraft, not just scheduled maintenance, but the unique characteristics and history of each individual airframe, which engines ran hot, which instruments drifted, which aircraft could be trusted at high speed, and which couldn't. Over time, Pakistani maintained F-6S became measurably more reliable than the same aircraft operated by other nations. Not because Pakistan received better aircraft, but because Pakistani maintenance crews invested the effort necessary to overcome manufacturing deficiencies. The pilots adapted too. They developed tactics that maximized the F-6's genuine advantages while minimizing exposure to its weaknesses. The aircraft's excellent climb rate, comparable to the Soviet original, became the foundation of Pakistani air combat doctrine. Pilots practiced climbing to altitude quickly, gaining energy advantage that would let them dictate engagement terms. They identified the altitude bands where the F-6 handled best, medium altitudes, where it remained responsive and maneuverable. They learned which conditions favored their aircraft and which favored potential opponents. They practiced gunnery techniques that compensated for the unreliable gun sight. As some pilots developed personal methods for estimating range based on target aircraft size. Others practiced until they could reliably hit targets at specific known distances through pure skill. They drilled emergency procedures until they could handle any malfunction instinctively without conscious thought, without hesitation. This process of adaptation cost lives. Training accidents claimed aircraft, and occasionally pilots as crews pushed to find the F-6's true limits. Wing Commander Asghar Khanna, a promising young officer, died when his aircraft suffered catastrophic engine failure during a high-G training engagement. Others survived accidents that destroyed their aircraft and ended flying careers. But gradually, painfully, the Pakistani Air Force transformed the problematic J-6 into an effective combat aircraft. It would never equal modern Western fighters. No amount of training could overcome fundamental design limitations or manufacturing deficiencies. But the F-6 was capable of defending. Pakistani airspace against the threat that mattered most, the Indian Air Force, and the ultimate test was coming. December 1971. Pakistan and India went to war again, in a conflict far more devastating than 1965. The trigger was the independence movement in East Pakistan, the geographically separated eastern wing that would become Bangladesh. Indian forces attacked on multiple fronts, supporting Bengali independence while seeking to permanently alter South Asia's balance of power. For the Pakistani Air Force, it was a fight for national survival under impossible conditions. Geography created the first problem. East Pakistan was separated from West Pakistan by over 1,000 miles of Indian territory. No air support could reach the eastern wing. It would fight alone with whatever was already there when war began. Indian forces enjoyed massive numerical superiority on every front. The Indian Air Force was larger, better equipped, operating on interior lines that allowed rapid concentration. Indian aircraft could strike Pakistani targets and return to relatively safe bases. Pakistani pilots faced odds that made victory impossible, knowing every aircraft lost could not be replaced. The F-6 squadrons were thrown into combat immediately. No. 15 Squadron at Sargata. No. 17 Squadron at Mazroor. No. 25 Squadron at Sargata. Pakistani pilots found themselves facing Indian MiG-21s, Su-7 South, Hawker Hunters, Nats, and other aircraft in daily battles over the subcontinent. The lessons learned during years of training now had to be applied under ultimate pressure, where mistakes meant death and success meant survival for perhaps another day. Squadron leader Sayyid Falazmal, ready and ace from the 1965 war, led an F-6 flight against Indian attackers targeting Sargata Air Base on the war's third day. His flight of 4 F-6s intercepted a formation of Indian Hawker Hunters-capable ground attack aircraft that could fight effectively air-to-air. The Pakistani pilots used their climb advantage, gaining altitude quickly before diving on the Hunters from above and behind the classic attack position every fighter pilot sought. In the ensuing dogfight, Azam's wingman, Flight Lieutenant Rashid Minhas, tracked a Hunter through defensive maneuvers. When the Indian pilot straightened momentarily, Minhas fired. The 30mm shells struck with devastating effect, punching through fuselage and wing structure. The Hunter trailed smoke, lost altitude. The Indian pilot ejected over Pakistani territory and was captured. But the engagement also revealed the F-6's weaknesses in stark terms. Another pilot and the flight flying officer, Khalid Mahmood, experienced sudden engine power loss while maneuvering hard against a second Hunter. A compressor stall. The compressor blades momentarily stopped providing proper airflow, a problem more common in Chinese-built engines than Soviet originals. The power drop nearly killed him. The Hunter he'd been engaging was suddenly behind him with a clear shot. Only aggressive maneuvering and his wingman's intervention prevented disaster. Mahmood limped back to base. Post-flight inspection confirmed the compressor stall a consequence of manufacturing variations affecting blade geometry. He was fortunate it happened when it did, early enough that he still had options. Moments later, during a firing pass, he might have flown into the ground before realizing what was happening. Throughout the 1971 war, similar stories repeated across Pakistani air bases. F-6 South achieved successes that validated Pakistan's decision to acquire them while simultaneously demonstrating fundamental limitations. Pilots had to be constantly aware of their aircraft's condition monitoring instruments, listening to engine sounds, feeling for vibrations that might indicate developing problems. They had to be ready to adjust tactics instantly if something went wrong, breaking off attacks that might otherwise have succeeded because the aircraft wasn't performing properly. Maintenance crews worked around the clock. The pressure of combat meant accepting risks that would never be tolerated in peacetime. Aircraft flew with problems that would have grounded them in training. Parts were cannibalized from damaged aircraft. Improvised repairs substituted for proper maintenance when time and materials ran short. The war ended after 2 weeks with decisive Indian victory. East Pakistan became Bangladesh. West Pakistan was left to rebuild from a defeat that cost half its population and significant territory. The Pakistani military had been comprehensively outfought, though not through lack of courage. The causes of defeat lay in political and strategic failures that no tactical excellence could overcome. But the Pakistani Air Force had survived as an organization. and the F-6 had proven itself capable of contributing to national defense, even against a superior enemy. The aircraft hadn't won the war, but it showed that Pakistani pilots could use it effectively in combat, that determination and skill could extract meaningful capability from deeply flawed equipment. The experience of operating Chinese J-6 fighters taught Pakistan lessons that would influence military procurement for decades. Pakistani planners learned that Chinese weapons offered real advantages: availability when other sources were blocked, affordability, freedom from political conditions. China wouldn't impose embargoes over policy disagreements, but they also learned the risks: quality control issues affecting reliability, manufacturing limitations, reducing capability, the need for extensive local adaptation to make Chinese equipment truly effective. Success required substantial investment in training, maintenance, infrastructure, and operational procedures that compensated for equipment shortcomings. Pakistan couldn't just buy Chinese weapons and use them as delivered. They had to transform them. For China, the experience was equally educational. Chinese engineers received detailed feedback about problems Pakistani crews encountered and actual service information, genuinely valuable, because it came from professionals with extensive experience who could articulate specific deficiencies clearly. Pakistani feedback drove improvements in subsequent production. The J-7, based on the Soviet MiG-21, showed measurable quality improvements. Manufacturing processes were refined. Quality control strengthened. The gap with Soviet and Western standards began to narrow. By the 21st century, Chinese aerospace production had improved enormously, producing aircraft that could compete with established aviation powers. The roots of that improvement trace back through decades of effort, including lessons learned from J-6 production and feedback from Pakistani operators. The relationship that began with the J-6 has continued and deepened. Pakistan has acquired multiple generations of Chinese aircraft, each improving on predecessors. The JF-17 Thunderjoint Pakistani-Chinese development represents the mature result of this partnership. Pakistani operational experience combined with Chinese manufacturing to produce an aircraft specifically tailored to Pakistani requirements. The roots of this success trace directly back to those first F-6 South in the late 1960s. The trust built through J-6 cooperation, the institutional connections between Pakistani and Chinese military organizations. Without that foundation, later developments might never have occurred. The individual aircraft have largely been retired now, replaced by modern jets with better performance and more reliable systems. The F-6 South that once filled Pakistani skies are museum pieces preserved as historical artifacts rather than operational weapons, but their legacy extends far beyond the aircraft themselves. They demonstrated that developing nations could operate sophisticated military equipment without depending entirely on superpower sponsors. They showed that determination and ingenuity could overcome significant equipment limitations. They illustrated the complex relationship between technology, manufacturing capability, and operational effectiveness that continues shaping military aviation today. For the pilots who flew the F-6, the aircraft remains a subject of complex emotions. Many recall the frustration of unreliable systems, the anxiety of flying aircraft that might develop problems without warning, the mental workload of equipment demanding constant attention, friends and colleagues who died in accidents or combat that better equipment might have prevented. But they also remember the satisfaction of mastering a difficult aircraft, the pride in fighting effectively despite limitations. Many acknowledge that the F-6's challenges made them better pilots, forcing them to develop skills and instincts that served them throughout their careers. The veterans are aging now. The generation that flew in 1971 is largely gone. Even pilots from later service years are retired, their experiences fading from institutional memory. The stories of those who operated these aircraft are being lost as they pass without recording their memories. But the aircraft they flew changed South Asian military history. Their achievements deserve remembering. Today, a preserved F-6 sits in the Pakistan Air Force Museum at Karachi. Its silver skin still gleams under fluorescent lights. Visitors walk past, most never knowing that this flawed, frustrating, sometimes terrifying machine helped forge a partnership that changed Asia, or that the men who flew it learned something no specification sheet could capture, that the measure of a weapon is never just the weapon itself. It's the hands that hold it. The story of the J-6 in Pakistani service is not a tale of perfect success, certainly not a story of superior technology. It's a story of determined people overcoming significant obstacles to achieve meaningful results worth remembering. Worth studying, worth sharing with future generations who may face similar challenges in different contexts. The aircraft are gone now, but their legacy endures in the institutions, capabilities, and lessons they left behind. In the partnership between two nations that outlasted the Cold War and continues today. In the understanding that technology matters, but people matter more. That equipment has limitations, but human determination can overcome them. That is the story of the J-6 in Pakistani service. That is what it means to find Chinese copies worse than the Soviet original and make them work anyway through determination and skill. That is the legacy that deserves to be remembered.